Good morning, children. Till now, you have studied about test of divisibility. So now let us continue the same thing based on test of divisibility. So chapter second, rational numbers. Chapter second, rational numbers. So call out children. Rational numbers. Under rational numbers, directly if we go for properties of numbers, you won't follow. Before going to properties of numbers, we try to understand the different types of numbers. Which are the different types of numbers? You already studied in 7th standard. Now we revise that one. Natural numbers, comma, even numbers, comma, odd numbers, comma, whole numbers, comma, integers, comma, rational numbers, comma, irrational numbers, comma, real numbers. Real numbers. Repeat all of you once again. What are those? Natural numbers, even numbers, odd numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Along with this, we are supposed to learn addition, subtraction, division, and multiplication. Now, let us go for just oral I am giving. No need to write anything. See, suppose if you take for natural numbers, what do you mean by natural numbers? Natural numbers commence from or starts from or begins from 1, 2, 3, 4. It won't be start from 0. It doesn't have negative integers. So only counting numbers. So wherever you go, suppose if you want to count, so how do you count 1, 2, 3? So that is natural numbers. So what are natural numbers? Natural numbers are counting numbers. Counting numbers. Take for number even number. So even number you know very well equally divides. So anything you take 4, if you take 2 2 you can share it, or 1 1 you can share it. There is no decimal there. So naturally we are call it as even numbers. Take for example odd numbers. So odd numbers are not divide equally 1, 3, 5, etc. Whole numbers. So whole numbers you know 0 included whole numbers. So there is no decimal point. That we call it as whole numbers. So take for integers. So integers are the numbers. It includes negative integers, positive integers, and 0. Okay, you know number line. Since UKG you are learning number line. So on that, what are the numbers are there on the number line? Center 0, right side positive numbers, left side negative numbers. So go for rational numbers. So rational numbers are very important. So that that is in the form of P by Q. That is Q is not equal to 0. Example P by Q. Q is not equal to 0. Q is not equal to 0. This is example. Example 3 by 5, 3 by 5, 7 by 8, 7 by 8, etc. etc. This is rational number. So go for irrational number. So that is root form. Example root 3, root 3, root 4, etc. These are irrational numbers. What are real numbers? So the rational numbers, in between rational numbers and irrational number is known it as real numbers. So this I introduced. Now let us pass on to examples. Now following examples, we will prove the different types of numbers. Now x plus 2 is equal to 13. Therefore, x is equal to 11. You know very well. What is this number? Oh, this is a natural number. This is a natural number. You can follow, no? Okay, the result is natural number. Go for another one. X plus 5 is equal to 5. X is equal to x is equal to 0. 0. What is this? It is not in the natural number. This is a whole number. Whole number 1, 2, 3, 4 continuous, but including 0. 0, 1, 2, 3. No negative integers. Go for next example. X plus 9 x plus 9 is equal to 3. X is equal to minus 6. What is this? Integer. Integer includes minus 6. Example only I am giving, not only particularly this number. Any number may be minus 7, minus 8, plus 8 also integer only. But I am giving example because minus number is not included natural number. Next, x plus 2x. X plus 2x is equal to 7. Therefore, x is equal to 7 by 3. This is a rational number. This is a rational number. This is in the form of P by Q. P by Q, I told you. Next, root 3, comma, root 7, etc. Irrational numbers. Irrational numbers. Children, all of you followed up. I have given examples also along with the explanation. We'll go for next properties of rational numbers. Properties of rational. Repeat all of you children. Properties of rational numbers. I'll go for first property, closure property. Closure property. Repeat all of you children. Closure property. First I will explain with the operation of numbers. So first you know already whole numbers and integers, rational numbers. So under whole number, for operation also I am going to show you which operation is applicable for closure property. You go through it. So first I will go through closure property first to whole numbers. Whole numbers. See, suppose you take under whole numbers addition. So 0 plus 5. 0 plus 5 is equal to 5. What is this? Whole number. Okay, that is a plus b is a whole number. A plus b is a whole number. Go for subtraction. Example, go for subtraction. 5 minus 7 is equal to minus 2. It is not whole number. Therefore, it is not a closure property. So next, let us pass on to closure property. Next, let us pass on to multiplication. 0 into 3 is equal to 0. So 0 is a whole number. Therefore, a into b is equal to whole number. So it is a closure property. Closure property. Go for division. No need to give example. So it is not a closure property. So which are the operations related to closure property? So one is addition and another one is multiplication. Only two operations under the whole numbers. So that is why you must know whole number. So all positive numbers including 0. By this example, closure property for the whole numbers only applicable addition and multiplication. Addition and multiplication. Clear children? Okay. Next, under closure property only, we'll go for integers. Under closure property only, we'll go for integers, children. Integers. So integers, what are integers? So negative numbers, positive number, and 0. Negative number, positive number, and 0. So here addition, subtraction, multiplication are integers, but division is not possible. So under integers, addition is possible. Any two numbers if you add, you are getting a number, integer, that is. Subtraction, any number if you subtract negative numbers also, it is possible under integers. So multiplication also, 3 into 2 is 6. 3 into minus 2 is minus 6. It is possible under multiplication or integers, but division is not possible. Division is not possible. This is the nature of the closure property. We'll go for rational numbers. Rational numbers, you know, rational numbers, p by q is not equal to 0. Q is not equal to 0. Here only possible, okay, under addition example, under addition example, 3 by 8 plus minus 5 by 7, minus 3 by 8 plus minus 5 by 7 is equal to 21. LCM is 56. 21 plus how much you are getting? 40. It is 40. So okay, so this is the way. So go for subtraction. See, it is possible. Now let us pass on to subtraction example for the rational numbers under closure property. Subtraction example, minus 5 by 7 minus 5 by 7 minus 2 by 3 is equal to LCM is 21. 21. So if you divide minus 15 minus 14, you are getting. So both if you add negative sign, minus 21 by 29 by 21. This is also in the form of P by Q. P by Q. Therefore, it is a rational number. So subtraction is also applicable rational numbers as closure property. Next, let us pass on to multiplication. Multiplication example, minus 2 by 3 into 4 by 5 is equal to numerator you multiply, plus into minus, 4 into 2 8. Under that 3 into 5 is 15. This is also in the form of P by Q, but division is not possible. Division is not possible rational number as rational numbers under closure property. You know, so far under closure property you have learnt whole numbers 4 operation, integers 4 operation, rational numbers operation. Some of the operation are not applicable for the closure property. Some are applicable. You have to mind it while you solving the problem. So let us pass on to next property, commutativity. Next, we pass on to commutativity property. But in previous classes, you have studied commutative property. That's all. Here, one word they have given. There is no confusion. The same property here also you are studying. A plus B is equal to B plus A. LHS and RHS. A value 3 is there. Suppose 4 is there. 7 is equal to 7. Like that. So whole numbers. So first here also operation whole numbers is equal to a plus b is equal to b plus a. So that is 3 plus 5 is equal to 5 plus 3. See, both if you add 8 is equal to 8. So therefore addition and multiplication, go for multiplication. Next, addition is over now. So go for multiplication under whole numbers. So under whole numbers, so a into b multiplication, a into b. Children, are you all following? So b into a. But so this is also applicable. applicable, but subtraction and divisions are not possible. Subtraction and division is not possible under whole numbers for the property commutativity. So here four operations we have done now. Which are the operations applicable for the commutativity under whole numbers? Addition is possible, multiplication is possible, but subtraction and division is not possible for the whole number under the commutative property. Is it clear? Next, we'll now let us pass on to integers, children. Whole number is completed. Now integers, under integers also four operations. So here addition and multiplication only possible, no subtraction and division. No subtraction and division, children. No subtraction and division. Followed. So once again, no need. So you know addition and multiplication. You take any two numbers, you do it four operation or two operations. So subtraction is not possible, division is not possible. Go for another one, rational. Whole number is over, integer is over under commutative property. So now we pass on to rational. Rational, you know, p by q, comma, q is not equal to 0, you know. So now take for addition. So minus 3 by 8 plus 1 by 7. 1 by 7 is equal to 1 by 7 plus minus 3 by 8. Minus 3 by 8. So a plus b is equal to b plus a. It is possible. Go for subtraction. Subtraction is not possible. Subtraction is not possible. Not possible. Okay, multiplication. Example. Minus 7 by 3 into 6 by 5 is equal to 6 by 5 into minus 7 by 3. It is possible, both the sides are equal, but division is not possible. So this is the commutative properties applicable for whole numbers, integers and division, children. So this is also okay. Another remaining one property is there, that is associativity. They have given associativity. This is also known it as associative property. Now the same thing, whole numbers, integers, rational number, operation. Let us see whole numbers, associativity, whole numbers. This is interpretation. Letters are a plus b plus c is equal to a plus b plus c. You put bracket. So left hand side second and third, right hand side first and second. This is the way you have to organize the numbers. Let us go for that. 7 plus 2 plus 3 is equal to 7 plus 2 plus 3. See, if you add and do it, so you are getting 12 is equal to 12. 12 is equal to 12. Okay, this is proved. So then addition is applicable. Whole number, 12 is whole number. Like that, multiplication is associative, division is not. Multiplication is possible, associative. Division is not associative. Okay, associativity property under whole numbers. So only two operation is possible. One is addition, multiplication, division, and subtraction is not possible. Go for integers. Here addition and multiplication is associative. Addition and multiplication is associative, but subtraction and division are not possible. Subtraction and division are not possible. Which is the other one? Rational numbers. Rational numbers. Here also rational numbers. Now rational numbers. Rational numbers. So here also addition and multiplication. Addition and multiplication is associative. Division and subtraction is not associative. Associative. Children, so far what are the properties you have studied? Closure property, commutativity, associativity. Under 3 also you have done operations, so addition, subtraction, multiplication, division related to whole numbers, integers and rational number. If you know all these things, so you can solve the problem very easily. And also many problems given in the exercise 2.1 in your textbook. Some of the examples I am going to solve, and also some of the concept I am going to introduce. Very simple. Though you are in 10th standard, if you ask the question, no, I have an experience, so 5 into 0 means, so 5. Some of the students are telling, no, not at all. 5 into 0 is always 0. 100 into 0, always 0. But you children forgetting. Don't forget that concept. So if you know very well those concepts, so you can, without mistake, you can solve the problem. Now let us pass on to some 4 concepts. So very easy, one line you learn. The role of 0. The role of 0. It is given in your textbook. Role of 0. 0 is very important. Adding, gaining, subtracting, decreasing, like that. 2 plus 0. 2 plus 0 is equal to 2. 5 into 0. 5 into 0. 0. See the difference. So that is why the role of 0 is very important. Next, role of 1. Role of 1. Role of 1. 5 into 1, 5. 1 into 5, 5 only. Okay, not only. Next, negative of a number. Negative of a number. Negative of a number. Minus 5 plus 5. Minus 5 plus 5 is equal to cancel. 1 minus 1 plus is there, is cancel. Reciprocal. 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 Minus 5 by 7 is equal to, you make it reverse, 7 by minus 5. So these are the concept you must know very well. Now let us pass on to example. Example, find 3 by 7 plus minus 6 by 11 plus minus 8 by 21 plus 5 by 22. 5 by 22. Now remove the bracket by multiplying the sign. Remove the brackets by multiplying the sign. 3 by 7 plus into minus, minus 6 by 11 plus into minus, minus 8 by 21 plus 5 by 22. Take LCM. LCM you are getting 462. 462. So if divide and multiply with the numerator, 198 minus 252 minus 176 plus 105. So minus minus you add it, plus you add 198 plus 105, 303 minus 428 by 462. 460 is equal to minus 125 by 462. 62. 4, 6. You know, children, LCM, no need to do once again. So you do it at home once again.